Dear learners, Assalamu alaikum. Once again, welcome to CPSCS online class and my channel Chemistry School. This is Shafikul Islam Shafik with you. Dear viewers, today I want to discuss about titration, and I am going to give you some techniques regarding titration which will be helpful to you to better understand. Dear learners, titration, what is titration? This is a measuring process. We can measure unknown solutions concentration. I mean, we have two solutions here. One is known solution and another is unknown solution. What is known solution? The concentration of a solution when known to us, then it will be the known solution. And when the concentration is unknown to us, then it will be the unknown solution for us. Okay. Dear learners, if I take it 10 milliliter of and 0.1 molar sodium hydroxide solution, this solution is known to us because of here, look at this, the molarity is 0.1 here, the molarity is known to us. Another, if we keep the HCl solution but the molarity is unknown for us, we want to determine the molarity of, the concentration of HCl by using this known solution. This is the titration. This is an experimental process. Dear learners, have a look on the figure. There's a figure. There is some arrangement of the apparatus. This process is volumetric analysis, we may call this. Here there is a glass apparatus. This glass apparatus is called the burette. And this burette having end, there is a screw and a stopcock, and this burette contains the solution of HCl here. If we rotate this stopcock or screw, then the solution from burette comes out to the another glass apparatus. It will be the conical flux. This is the conical flux, another glass apparatus, dear learners. Here, look at this. There is a solution here, sodium hydroxide. Sodium hydroxide, here we contain 10 milliliter and 0.1 molar sodium hydroxide. This solution is known solution and this solution is unknown solution. We take a stand here to keep the burette, and look at this, dear learners. When we add HCl to this solution, then this acid and base. So there is a titration between acid and base. We have some titration, mainly two titration here, acid and base titration. On the other hand, another is redox titration. And now I am talking about the acid base titration, dear learners. Here, when acid comes to the conical flux, then acid and base react each other, and neutral, when neutral the total volume of sodium hydroxide, then we stop the cork, stop the screw. When the reaction will be completed, how can we understand the reaction is completed? How much amount of hydrochloric acid is needed to neutral 10 milliliter of sodium hydroxide. And that is why we use a substance to indicate the endpoints of the reaction. This is the indicator. The indicator means indicates the endpoint, indicates the endpoint of reaction. We know that there is some indicators we have. Most commonly used indicator is litmus paper. You know very well. Whether the solution will be acidic, will be basic or neutral, we can easily find out by using litmus paper. But here we use the another substance which is made from weak acid or weak base. This is the indicator. We use here methyl red, methyl orange indicator. The indicators are colorless in basic medium. If we use some drops of methyl orange here, methyl orange, dear learners, methyl orange. Then this indicator doesn't show any color here, but when the solution will be neutral or acidic, then the indicator, I mean methyl orange, shows its color. Methyl orange shows the violet color at the end of the reaction, I mean in neutral medium. When we can get the color of this reaction, then we stop the screw here. Then we just find out how much amount of volume in volume the HCl is needed to 10 milliliter neutralize the 10 milliliter solution of sodium hydroxide. Look at this here, 6 T to 20 milliliter needed value. What will be the value here? 40 milliliter. This is the 40 milliliter needed value for hydrochloric acid to neutral the sodium hydroxide. The related reaction is here, dear learners, HCl plus sodium hydroxide, and salt and water will form here. Salt and water will form here. Okay. Here, look at this, dear learners. To know this, here the volume here now, the acid volume is Va, and here the volume of base is Vb, and the concentration of base is Sb. Here, look at this. The volume is now we can get from the burette reading. The volume of sodium hydroxide is given there. Volume of concentration is given there. Now we can use a volumetric equation, and then we can easily find out the concentration of HCl. We can use a equation A into Vb Sb, B into VASA. Here, look at this, dear learners. Vb means the volume of base is given there. Sb means the molarity, I mean concentration of base is given there. And the volume of acid is also we can get from the burette by the volumetric process. And our target to find out the concentration of the acid. By using this equation, we can easily find out the concentration of acid. Here, the concentration of acid is it will be determined by the using of sodium hydroxide solution. This total process is called the titration, dear learners. And here there is another two term, A and B. A is the mole of acid which we will get from the reaction. Here 1 mole of acid is we can get from the reaction after balancing this equation. You should balance the equation first. Then 1 mole of acid, I mean A is here for 1. And also there is another substance base, the B. Here B is the mole of base from the reaction, mole of base from the reaction. Here B is the mole of base, and here from the equation we can get the 1 mole sodium hydroxide is take part in the chemical reaction, so B will be the 1. Then we can easily get the value of the concentration of acid, dear learners. Okay, that's all today, dear learners, regarding the titration. And thank you for watching my videos. Keep watching my next videos. In the next videos we will solve some problems, mathematical problems regarding the titration. Okay, thank you all. If you like this video, please do share, comments, and don't forget to subscribe.